All right, displacement graph. A mail carrier leaves the post office and drives 22 kilometers in a northerly direction to the next town. She then drives in a direction of 60 degrees south of east for 47 kilometers to another town. What is her displacement from the post office? So in this class, we've learned displacement and distance are the same thing, because that gave us an introduction to this class. But now we're going to start splitting those definitions. I want you to draw this picture. Oh. This picture. Yeah. So you've got an A, you've got a B. That's where you start, that's where you end. But let's say a car drives the long way around, goes through all the neighborhoods, and then gets to B. Distance is how far the car traveled total. But displacement is how far the beginning is to the end. Okay, you see that difference? You either are going to solve for distance, which is the total amount traveled, or you're going to solve for displacement, which is how far truly are you from the beginning to end. Okay? That's one way of looking at displacement versus distance. This problem is asking for displacement. Otherwise, we could just add 22 plus 47, and then we get the answer. We need to find out how far is she from the beginning to the end, and what direction, like what degree. So we're going to do this one step at a time. Grab your pencil, and I want you to draw post office to the next town. Draw one arrow, and it's 22 kilometers. After you've drawn your arrow of 22 kilometers traveled, the mail carrier has reached the next town and now is going to travel 60 degrees south of east. So give yourself an east. Right? East is to the right. And then 60 degrees south means you're going to be moving below the east. If it says 60 degrees north, then you're going to go above the east. But we're going to go south, 60 degrees. It doesn't have to be exact. It just has to be less than 90. 90 is going right back to home. So 60 degrees, and then the length of this traveled distance is 47 kilometers. Now, if the question asks, what is her distance from the post office? You just add 22 plus 47. But we're asking for how far is she from where she started? How far is she from where she started? Truly. Okay. So we need to find this arrow here. Okay. We need to find the green arrow. And this is what was in your waterfall. How do you solve for a distance that is a triangular shape, but not 90 degrees? You know one of the angles, and you know one of the lengths. Technically, you know two of the lengths, but one of the full lengths. This is geometry. So this is where it comes in handy, and this is why geometry is taught before physics. If you forgot about geometry, this is going to be a refresher for you. So, Xavier, do you have a suggestion how we solve for C? Like, what's one step we might need? C can be the yellow line. We have to decide which is going to be C. First of all, why did you use letter C? Did you say letter C? I said letter C? Okay. Let's say we don't use the word letter C. I think I read the notes and then I said it without thinking. What's one step, without using letter C, what's one step you would take to solve for this green arrow? It's geometry, like you said.
But wouldn't we like? I know it has something to do with the other two.
Okay.
I don't.
Okay, so you're thinking of the warm-up? Like this? Are you thinking of this?
Yeah.
Okay. So this is something you have to have in your notes because it's going to be used often in physics. Every triangle that's at a right angle can be used with trigonometry and geometry. Actually, I think geometry is in trigonometry. You're going to use this right triangle to solve for the lengths of the triangle. So it's going to be a hypotenuse, an adjacent, and an opposite, just like our clinometer problem. And there's going to be a sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tangent theta equals opposite over adjacent. Now, I was tempted to just print out these little squares for you, and then you can just take it to your notes. But we're going to use this so often that you should start to get comfortable drawing triangles and drawing the actual formulas to solve for a distance. In this case, actually displacement. But I did forget how long it takes to copy all this information down. So I think for period 4, I will be printing these out. I apologize. It's always a balance between efficiency versus long-term memory. You'll have this in your long-term memory more because you're writing it down, you're processing it, and that'll be the benefit. So do we have a right triangle? Yes or no, class? We don't. So you have to make it a right triangle. So draw a dotted line underneath your 22 kilometers, and then a dotted line that connects your first dotted line to the end of the trip. And then you use a box to represent the right triangle. So now we have something a little more familiar that Xavier recognizes. This can be that. Right? This can be that. When we solve this problem, I want you to think of this triangle side by side. We've got a hypotenuse of 47. We have an angle that we can solve easily. What's the angle between the red and yellow, class? 30. How'd you get 30? 90 minus 60. All right? Does anyone need that repeated? How did we find theta? How did we find this? Shauna says 90, which is all of this, minus 60 gives a theta. So now we're on the track to solving for the opposite and the adjacent of this triangle. It's right here. And this is right here. And we're going to use these to solve for that and this. So let's do it. I'm going to scoot this over here. We want to find an opposite first. So which of these three uses opposite and hypotenuse? Which of these three? Someone shout it out. Sin. It's actually pronounced sine. But you're right. It is spelled sin. So let's go ahead and use sine theta equals opposite over hypotenuse. That's the formula we're going to use to find this length. Sine is theta. Sorry, sine is theta is 30, and the opposite is 47. Everyone see that? this triangle is this triangle, then sine theta is sine 30. If this opposite is this opposite, then we can say we want to solve for opposite. If this hypotenuse is 47, then hypotenuse is 47. Now let's solve. This is just like the tangent problem in our clinometer problem. The student's not here. Natalie, what is sine 30? .5. And what do we do to get opposite by itself in this formula, Natalie? How should we? Okay. Everyone see that? Multiply both sides by 47. And then what do you get, Natalie, if you do 0.5 times 47? 23.5 equals opposite. Let me make this a little neater. So that is step one. That's a big step one. You got to draw your pathway. You have to make it a right triangle, and then you plug it in for sine, and then you have 23.5 as your first opposite. First length. Because if we find this, and we find that, we use Pythagorean theorem to find this. But that's our third step. We got to first do our second step after our first step. So now let's find our adjacent. Class, if we're trying to find the length of this adjacent side, which is the same thing as this, which of these three functions should we use to solve for adjacent if we have hypotenuse? Cos. Spelled cos, but called cosine. Sine, cosine, tangent. So let's write it down. Adjacent. I have it right on this side. Adjacent over hypotenuse is cosine theta. Theta is 30. So it'll be cosine 30 equals adjacent. We don't know. We know part of it, so we'll use that known part later. But we need to find the length of the whole adjacent. Adjacent divided by hypotenuse. So it's going to be cosine 30 equals adjacent over 47. Let me ask... Is Anthony in this class? Gonzalez? I don't think so. It's not here. Elijah. Grab a calculator. Put in cosine 30. Tell me what you get. Okay, and we round up to 8.7 equals adjacent over 47. Elijah, how do we solve for A? How do we get A by itself? We have to do the opposite of what's happening to A. Right now, A is divided by 47. So you do the opposite. Which is, what's the opposite of divide? Multiply. So we're going to multiply both sides by 47. Do this in red. And what do you get, Elijah, if you multiply that by 47? You get 0.87 times 47. You should get 40 something. Try again. 40.8, but 40.89 because we want the hundreds. I think I got them all red. So that is our 40.89 is our adjacent. But that's the total length of this side. The red plus the dotted line. We want just the dotted line. So we're going to subtract 40.89 minus 22. Xavier, what's 40.89 minus 22? 18.8. 18.89. All right. So now we have the length and the height of this triangle. 18.89. Can we find the hypotenuse of this green line? Bradley, do you remember how to find the hypotenuse? Write this down. A squared plus B squared equals C squared. If you know what A is and if you know what B is, you can find C as a result. So let's say our triangle is A 18.89, B 23.5, and then C. This is why I was calling it C earlier, Xavier. I was like reading the notes and not making the connection. But we got A, B, and C of this triangle. We're going to use the Pythagorean theorem to find the final length. So let's plug in, Bradley. What do I put in first? If it's A squared plus B squared equals C squared. 40.89 is our total length of the adjacent. That's the total length of this, and we subtracted 22 from it to get just the length of this, because we want the length of this so we can find the length of that. So use A squared plus B squared equals C squared. That's B. A is... Okay, I switched them around. Here, bear with me, class. I made this B and this A, but Bradley's on the right track. Hello. So go ahead and do this. $23.5 squared plus 18.89 squared equals C squared. Yeah, go ahead. So Bradley, go ahead and do the math for us. 23.5 squared plus 18.89 squared equals C squared. For this, you should be able to put it all in your calculator from left to right. Okay. And we want to find the square root of that because it's C squared. That's correct, 30.15. Let me put a decimal in there. All that work has come to an end for the first part of this displacement. Okay, so now we have this triangle that gives us 3 different lengths. We know that the post office carrier traveled 30.15 meters, but in what direction did the post office person travel? So I have this triangle here that represents the same thing that's in here. Okay, this goes in there. We found 18.89, 23.5, and 30.15. Thanks to Bradley and his classmates. the last thing I want you to find in this physics problem is the angle. The angle between south and the direction the person traveled. Because that is displacement. The displacement is the exact coordinates where the person ended up. So we're going to use one more function from trigonometry and geometry. We need to solve for theta inside our little triangle. And let's use our opposite and adjacent for that. Class, which of these three uses opposite and adjacent? Sine is opposite and hypotenuse. Tan, or tangent. So we're going to rewrite tangent theta. And we'll put a little 2 at the bottom so that we know it's not the same theta as we used earlier. Right? We have theta 1 and theta 2. We're going to plug in opposite and adjacent. Good thing we solved for those two. Christopher Juarez, give us 23.5 divided by 18.89. $1.24. And that's tan theta 2 equals 1.24. Christopher, how do we get rid of the tan so that theta is by itself? You know what that's called? You remember what it's called? Tan minus 1? It's called inverse tan. Inverse tan. So class, take your calculator, hit second, and then hit tan, and you got yourself an inverse tan, just like square root. Second square is square root. Second tan is inverse tan, and put in 124. What do you get? What's inverse tan 124? 1.24. Yeah, that's correct. And let's make it 0.1. I get 0.12. So let's fix this. I get 0.12. Thank you for the reminder. And that's how you solve this beast of a physics problem.